Hello all, we are here for one more lesson of this VariCAD 2016 training course, and the topic we are going to see in this lesson is about the calculations we have inside the software. So we can assess these calculations, and we have a lot of them. We can assess them in both 2D or 3D. So if you come to this objects menu, you have these calculations and you have a lot of possibilities here. Okay, I will show you 2 or 3 different examples so that you can get the idea of how to work with this. In 3D, you have also objects and then mechanical part calculations. You have again the same options, so you can assess it in one side or on the other side. So starting calculations, you have all these types: compression springs, tension springs, square keys, plunge shafts, bolted connections, round pins, bearings, and some other more. Okay, let us see 2 or 3 examples. For example, bolted connections. So the idea behind these calculations is to dimension different mechanical situations where you have to choose a mechanical component. So in terms of the bolted calculations, let us try to choose something. Okay, we have a couple of options. For example, I want to dimension one bolted connection. I have one external force which I can dimension, for example, in 500 newtons. I have this allowable stress which I can say it's 420. Some of these values you need to know a little, and you have to know more data about the class that you have on the in this case of the screw and the values, because some of these things are standard. Okay, we are just making an example, and I want to say, for example, this screw is a M3 screw. I don't have any conditions of preload. Okay, it doesn't matter, and let me just do the check. And for these situations, what the program told me is you can use it because the screw is sufficient. But for example, if instead of having 500 newtons, if I have 5,000 newtons, I can do the check again, and now screw is not sufficient. But I can work with a program something like this. Okay, I want to put the smallest possible, also because of cost. So M3 it's not okay. Let's try the M4 and check. Still not okay. The M5 check is sufficient. So you can use the program also in this kind of let us trial and error. Okay, so this is one possibility. For example, we can have, for example, a bearing which we can give some information also, and the type of load: constant, impact, linear, or out of balance. Let's put the worst situation, out of balance. Constant force, actual, face to face, and control. Okay, now we need to input which are the forces here. So I can have a radial force of also 500 newtons, unbalanced force of 100. Let us say this one is 200. This is rotating at 1000 reps per minute, and I need this to 5000 hours for life of my component. I can give some coefficients of reliability and static safety. Okay, something like this. Okay, and check. Bearing, and need to choose a bearing for sure. One bearing one simple one, doesn't matter which one. Insert, and now check. Bearing does not satisfy the conditions. Okay, just play a little around this. Give this 500 hours and not 5,000, and do the check now. Still not satisfy. Okay, decrease the revolutions. Okay, only the static safety, just to see. Okay, I'm doing this. Okay, going a little below. Okay, now it's sufficient. For sure, for a bearing it was not the proper way to work with it, but just to show you how can we work with this. You have also the results here, okay, for the calculation done, and you can save the result outside and whatever. Okay, this is quite interesting and very open. Let us see one more about the shafts and beams, which I think it's also quite interesting. So beam properties, we can define, for example, 2 meters. Allowable stress, let us say, for example, 100 megapascals. 100 elements, okay, it is okay. So the sections, we can add one section. For example, it can be a square, a circle, let us say a circle, and 2000, sorry, 50, okay. The supports, I will add one movable one at 200 of the beam, it is here, and we'll add one more fixed at this distance on the beam, and okay. Now the loads, I can add several types of loads. For example, 1000 newtons, 30 degrees, and at 1000 millimeters, okay, a normal force. I can add, for example, a torsion moment, let us say 1000 also, at 100. I can say one more, distributed load, for example 300, and for example here this 500, and here at 400, and here 600. Okay, something like this. Okay, you have all the conditions inserted, and now do the calculations. It's making the calcul, and now you can have the graphics. Okay, shear force, reduced stress. This is a help. You can see some of these values. Axial displacement, axial force. Okay, a lot of things you can analyze and check. Okay, you can save results, you can display it. Okay, reactions, strains, internal effects, stresses, whatever. This is quite complete. You can save all these things also in whatever you want in this format. But the idea is you can have these calculations quite easy to available for you in both environments. This is not a finite element module in neither of the calculations. This is quite simple, but on the concept of a mechanical program and on the idea of developing assemblies of machines or mechanical assemblies, you can dimension some of the most normal parts you insert in your assemblies, assuring that what is done, it is correctly done. Okay, I hope this was clear. Anyway, I would like to leave you one additional information about these calculations. We are going to release in a couple of weeks a couple of videos teaching and showing how to calculate some of these things with greater detail, not in VariCAD but as a theoretical concept. And I think for the ones among you that are interested in this information, please subscribe our YouTube channel, because this way you will receive the information when we start to release these videos.